Hydrates are a special type of molecule. They're molecules that actually have water bound to them. And I don't mean that they're wet molecules. I mean they actually have water that's physically, chemically bonded to them and part of the molecule itself. If they don't have water bonded to them, we tend to refer to them as anhydrous, but they can have multiple molecules of water bound to it, and that will change the formula. And so you have to be careful when you say, I want sodium chloride. It might have water and different amounts of water bonded to it. We use the same prefixes to indicate the number of water molecules, just like we did in covalent molecules. So remember mono and di and tri and so forth. So let's look at this one here. This is just good old copper sulfate, but you can see that it's got two molecules of water as part of it. And you can see that we indicate this bond here by a little dot there. That's not quite as strong as a line would be, but indicates that there is a bond. So this is copper sulfate, right? But since it has two, we call it a dihydrate. This is calcium chloride. It has four. We'd call it a tetra. This one here is barium hydroxide. It has eight. We'd call it octa. And the thing to remember is for any particular molecule, there could be multiple forms. So you could have barium hydroxide, octahydrate, or trihydrate, or pentahydrate, and so forth. So be careful when you look at the formula. Don't just assume what it is. Okay, now since the water is actually part of the molecule, it's chemically bonded, we have to consider it as being a component of the molar mass. So we're going to calculate our molar masses the same way, but this time we're going to add water, and hopefully everybody remembers water is good old 18 grams per mole. Good number to memorize, so we don't have to keep doing it. So let's take a look. Now this molecule here, calcium chloride, but we've got three, so this would be trihydrate. And we got to add them all up together to figure out the molar mass here. Let's take a look. Calcium is 40. Chlorine is 35.5 times 2 is 71. Let's add those together. That means so far we've got, what, 111? But you've got water, which I said was 18, right? And you got three of them, so that's 54. So we add it all up together, and that gives us, let's see, how's that? Should be 5, right? How do you think it's 165? That looks like there was a mistake there. Okay, fair enough. So the total molar mass is 165 grams per mole. Now the good news is it's pretty easy to remove the water. Since it's a loose chemical bond, you can just go ahead and heat it up, boil it off, and then you're left with the anhydrous portion. And because we can weigh these things, we can easily figure out how many water molecules it must have been. So let's go ahead and try an example. What if I have 100 grams of calcium chloride? And it's a hydrate, but I'm not going to tell you how many water molecules. And then I go ahead and steam it. I boil it. And the new weight is 64. So it lost. It went from 100 down to 64, which means that it lost 36 grams of water. I chose that number because I knew that the molar mass of water is 18. So in other words, it lost 2 moles of water, which means that the formula must have been calcium chloride 2 dihydrate. Pretty easy to do, right? We can also do the same trick here by figuring out what the percentage is, right? So the percentage of water, again, remember, equals the mass of the water divided by the total mass, and we've done these calculations before. Let's go ahead and try one. What percent of sodium chloride tetrahydrate is actually the water? Let's take a look. Well, once again, we remember water is 18 grams per mole times 4 gives us the water weight is 72. So that would be this one here is 72. What's the total weight of the molecule? Well, sodium here is 23. Chlorine, remember, is 35.5. You've only got one of each this time. So we'll add those two up. That would be what? 58.5, right? But you have to add the water into it, right? The water was 72, so we add those all up together. I get 130, and that would be this guy over here. Let's divide the two, and we get that that molecule is actually 55% water. which is a lot of water for a molecule. So you can see that you just cannot avoid that.